If you would like to learn deep learning with practical coding examples, please subscribe to Murat Karakaya Academy YouTube channel or follow my blog on Medium. Do not forget to turn on notifications so that you will be notified when new parts are uploaded. You can access this collab notebook using the link given in the video description below. If you are ready, let's get started.
Hello, sir. Good
Hello,
afternoon.
Noman. How are you?
I'm fine, and how are you?
Thank you. So today we are gonna learn what we have done during last 2 weeks, right?
Yes, sir.
So I'm really excited about that because it has been 2 weeks, and
Yes,
last time we agreed to try to some toy project to see that if we can locate the body positions or like
yes,
that, right?
yes, sir.
So you can share your screen,
Uh,
your presentation, if you
yes, sir.
like.
Yes, sir. Sure. Actually, it was not that much of a difficult task because, there are a couple of already trained architectures for this purpose, as I found over the internet, and that we can utilize for this purpose. So that is
So
what
by the
I
way,
did as
Noman, by the way, please share the links that you all already used to prepare this presentation with me so that I can
yes.
add these links to the description of that video. Okay. So anybody can
Okay.
access.
Yes.
All right. So please
Yeah.
let's start with our aim. What was our aim? In the last discussion, you would like to
Yes.
work on the robot vision, and then we just jump
Yes.
out to the some techniques how to teach a robot to imitate
Yes.
a human body movement, right? Then we
Yes.
discussed that
Yes.
we would like to have some simple application
Yes.
and to learn or to get our hands dirty, hands-on training. So
Yes.
please give me a summary. What was your idea? And
Yes.
then step by step explain how you move on with these ideas. Okay,
Yes, sir.
please.
Sure. So, our main idea was to perform imitation learning as to when we can show our agent, or in our case, it's a robot, that how a task is performed, and then our desire is that the agent performs that task or learns how to perform that task. So, in our case, we are targeting that if we have a humanoid robot, a robot that is have same shape or joints, near to or the similar shapes or joints as human body. So we want the robot to teach him how to perform some specific task. So for that purpose, one way is that usually or conventionally people have been doing is that we place some sensors or motion sensors or placement localization sensors on the human body, and then when a human moves his arm or his some joints, then we can track its movement in the form of electrical signal, and we give it to the robot so that a robot can perform that. Another possibility of it was if we can just show the robot a video of a person performing the task. So from the video, if we can get some useful information of how the human performed some task, what movements the human performed, or what movements the specific joints of a human performed, then we can convert those parameters in terms of the robot's body, and then we can teach the robot how to perform some specific task. So
So
this was
basically, we expect that providing a movement, a complete movement or a complete task done
Yes.
by a human being in a video, the robot should split the movement into sub moves and understand their parameters like the degrees, the minutes, or the length, or the force, I don't know, then
Yes.
translate these parameters for itself so that it can imitate these tasks by applying each step, understanding, of course, each step, and then apply each step to its own body. Am I right?
Yes, sir. Yes,
Okay.
sir.
That's the
Exactly.
our main approach.
Yes, sir. Our main approach is that. So, in the last meeting, we decided that first, my professor told me that first we need to create an architecture that can do the most initial task, that to detect the pose of the human, and to detect the movement of the joints of the human in any video. So that is what I did in the past 2 weeks, and I performed this using this media pipe architecture. It is an open source architecture available over the internet, and we can and secondly, using OpenCV, and it is the CV2 version of OpenCV. So first, let me import it also, and then after importing it, we can load the pre-trained solutions of this media pipe architecture into our program as drawing tools and the holistic model. Drawing tools is the model for drawing live joints and their connections, like drawing the main human pose in the video. And a holistic model is the actual model that detects those joints and those their connections. So I
They
have just
provide some parameters like the degrees to each joints or
uh,
changing time, the joint positions. Do they provide you the,
yes, yes, exactly.
okay,
They provide all the coordinates of a joint that they detect. We can extract those coordinates.
great.
Yes. So there were two possible versions or the applications we could perform this. One is for live video, like we can perform it using our webcam, and whatever the webcam sees, it will detect if there is a human body, and it will detect the joints and their connections. So, sir, should I run this one right
Yes.
now? Okay. I hope it's not a problem because I'm already using webcam in the Zoom. Let's see.
Sometimes you cannot run the same camera with two
Yes.
applications. So if you have another camera, maybe you try, or you
Mm,
can stop sharing your webcam in Zoom, so you can
yes.
share it with the Jupyter Notebook.
Yes, I think. And that is the thing because it's not being starting up. And I think that is the problem. Yes. It gave the error because it's
Yeah,
not
it is
using.
already being used. So if you like, you can stop your sharing, the Zoom sharing webcam. You can
Yes.
stop.
Stop the video, you mean, right?
Yeah, I mean the stop sharing your,
Yes.
yes. Now you can try to
Okay.
run again.
Let me try this. Okay, yes.
Oh,
So can you see, sir?
yes, I can see it.
Yes. So this is actually the part of only the human joints and their connections detection. Actually, with using this holistic model, we can detect all the face landmarks as well, like including the lips, nose. But I have commented it because it's not our main purpose to detect the face landmarks right now. And similarly, hand joints, like the very mhm, right now it's just showing these small three joints, but it can actually detect these finger joints as well, but I am not performing this right now. I'm commenting it. So mainly I'm using this pose connections and pose landmarks part of this holistic model. So this is, as you can
I
see,
think you need to stand up, right?
yes, this is how it can.
Okay, I see.
So like right now, and if I just move the camera a little bit down, it can perform, it can detect my body as well. So it's like that.
What about legs?
Yeah, legs as well. If I think
Okay,
I
I
need
see, I
to
understand.
raise my
Yeah,
legs
all
like
right.
that.
Okay,
Yes.
so I
So
understand that it can easily
yeah.
capture your joints, right?
Yes, yes. I will show later, like in the second step now, through the saved or stored video, and in that video it can detect all every joint. So we will be able to.
Can you review the code for us? Just how to use this already
Yes,
trained model?
yes. It's
It
quite
is very
simple
basic,
actually.
I think.
Yes, it's quite simple actually. Like initially starting, you want me to define it or share it?
Just review the code. So tell us that what is going on in the code simply, like
Yes,
in 1 minute, so we can
mm,
understand that what's happening in the code, how to
okay.
use the train model actually.
Yes, it's really easy, not that difficult. So we are just importing the holistic model right now here, like with mp holistic.holistic, and these are some parameters like minimum detection confidence and minimum tracking confidence as zero point 0.5, and by we can just set this zero point 0.5 confidence, as I also like from where I got the inspiration. So these were the parameters and they work fine, in my case as well. So then we create a loop like while cap is open. Cap is actually, initially we defined cap is equals to cv2 video capture and zero. So video capture is like capture the video, and zero is like the device from where we are capturing video. So in our case, this is zero is actually
Webcam
the
itself.
number for my webcam. So okay, so this was zero. So in some case also this zero might not work. So you will have to try one, two, three as well until it detects your camera. So this is that thing. And while the camera thing is open, while it's recording the video, we create this loop, and in that loop we read this video capture and we get the frame. And from that frame, initially when this reads the video, it reads it in bgr, not rgb. So initially we will need to convert it to rgb, and then we will perform the holistic process image. Like it's actually right now here it is processing of
It looks like the
detection
predict,
detection
right?
of joint.
In neural network, it is the
Yes, this is
predict method,
actually,
right?
yes, this is the main line like this that predicts and estimates the pose. And after estimating, we again convert it to bgr, like its initial form for rendering again to the screen. And then we can choose which parts we want it to draw, because we have detected every part, every joint, every connection, but now these things are what we need it to draw on the display. So we can use the face landmarks, right hand, left hand, both separately. We have option if we want to display both of them or one of them. And then the pose detection, as I did here recently. And these are the options we can play with, this the colors of the drawing and the thickness and the radius of the line that is being drawn.
Actually, these are the parameters for the output of the model, right?
Yes, for the output of the model, what we will see. And here I flipped the image because usually the webcam give the
Mirror image, right?
yes, mirror image. So I needed to flip it and then resize a little bit because due to the pixels, sometimes the webcam window is very small on the
Mm.
screen. So I just resized it to my screen size. And then this is also an if part where we are just monitoring our keypad thing, the key Q. And if we just press the Q, it will release the camera and it will
Quit, right?
close it. Yes, it
To
will
quit.
quit it. Exactly. So that is the code. And
But by the way, Noman,
yes, sir.
you mentioned that this train model actually not only drawing on the screen the junction points and their connections, but it can also provide some parameters about them, right?
Yes,
So
yes.
does it write to a log or what it does? How can we get these
It can just
analysis of the junction points
yes, yes.
parameters
It can print it. Actually, I did it,
in that
but
results?
I did it actually, but I actually decided to delete it later, that command, for just the purpose of like this time I needed to draw it. I have it there. We
Okay.
can just like put that print command and it will print it here as an output. It
Okay,
stores the
I'm just interested in seeing how the model outputs in what structure. It can output the relationship or the detection of the junction points first in the
yes,
three dimension. In three dimensions, it
yes,
can locate right each
yes,
junction points and maybe their relationship and
yes.
tracking these junction points and the movements of these junction points throughout the time, I believe. So
Yeah,
there should be some data
here actually.
structure. So I am interested in that.
Yes, yes. Here is that print command. I forgot this, and here we are present. This as we got the results here, we just need to write print results face landmarks, and it will print it. Let me just copy this. Or okay, yeah, let's run
Have
it.
you tried? Have you tried
Yes,
to get that structure?
yes. Okay. First, I will need to stop my camera right now. Okay. Mhm. But yeah, so here
Hmm.
we can see this is printing my face landmarks live, like that. This is actually the face landmarks, not my pose landmark, as I just wrote their face landmarks. Actually, I will more need to more better understand it as well, because
There are many landmarks on your face. As far as I've seen, 5 or 6
yes,
locations.
yes, a lot of them.
So should I think they should somehow be named, right? Labeled
Yes.
somehow. Because now I can't see any labels.
Yes, I think in the basic model it's not labeled, and I will have to dig in a little bit more
Okay. So
for getting.
for the next step, we
Yes,
need to understand how these landmarks are labeled and how the algorithm or the model tracks
yes,
these landmarks throughout the time, during the time, you know.
mhm,
So because to train a robot, we need to tell them that this landmark is corresponding to this location on your face. And during the time, this face feature should be moving to that three-dimensional space location in space during the time. So to imitate this, right? So we need to really understand how what is the output from that model and how can we convert from this model output to the instructions to a robot, right?
yes, sir. Exactly. I will gonna do it surely
So dig in a
in the
little bit
next one.
more about how to get this output, okay, and the structure of the output. You need to
Yes, the
understand,
land.
right?
Exactly. Yes, like the positions, actually, the numbers, because those were, I think, useful mainly for us. The
But we don't
numbers.
have time steps, right? We need to have the time steps as well.
Yes, I think.
Otherwise, we
Yes.
cannot imitate the movement, right? Without time. timestamp.
Yes.
We cannot,
Yes. Yes,
and
sir.
without labeling the position. So we need to label the positions and then track these junction points or the landmarks. And then we need to track the landmarks during the time of the movement of
Yes.
the goal movement.
Yes, sir.
So we need to get into a little bit insight and understand and gain some insight about the output. So if this model cannot support the outputs that we suggest to have, we
Yes.
might need to change the model, for example.
Yes.
But
Yes.
I guess that, or we need to write down some code to convert, translate from the landscape
Yes.
and the time so that we can use in the imitation of the movement.
Yes. Yes, sir.
Okay, let's continue with your
And
presentation.
okay, sir. So, but my laptop is actually a little bit lagging right now. It's not that much, good.
Could you
Or
speak
power.
up, please? Maybe you are away from your microphone. I'm
Yes,
hearing
yes,
you
sir. I am
clearly.
right here.
Thank
Actually,
you.
my my laptop is actually lagging a little bit right now, so that's why I was just being worried.
Okay, no problem.
And it's not that good, Like I'm going to change my laptop a little bit, Professor, but it's
Me too. I need to upgrade my laptop as well.
yes, sir. So I think it's still in the position of yes. I think we can run it right now. I hope
This is
it
for
not.
the offline videos, right?
Yeah, it's for the offline video, and here I am just instead of recording it from the camera, I just need to load my pre-saved or stored video, and it can perform the same very similar task here again. So let me run it. I hope it not gets stuck.
One question for you. Have you tried to
Yes,
run
sir.
these on Colab?
On call, yes, no, sir. Actually, not on Collab because initially I didn't know how to load stored media in the Collab. So that's why I just initially started to work with Jupyter. But later I searched a little bit also over the internet, and I found that we can actually load our media on the Collab as well
Yeah,
by
it is very
uploading it to the
easy.
Google
It is
Drive.
very easy. Actually, I have a video
Yes.
on my YouTube channel, Murat Karakaya Academy YouTube channel, how to upload the images and the videos. It's very easy. Actually, basically, you can connect your Google Drive to the
Yeah.
Colab, or you can just
Mhm.
give a link to your video from YouTube or GitHub, for example. So it can run easily. Why I did ask you, if you use your Colab, because Colab can support with GPU and for free.
Oh,
So you
I see.
can run it. So you don't need to depend on your older laptop. That's what I am asking. And
Okay.
you can share the notebook from Colab or GitHub easily. So anybody can imitate your work easily.
Yes.
So
Okay.
I
So
basically
I think it will
kindly
be
request
quite
you
better.
to develop your
Yes.
code in Colab and
Yes.
then post it from Colab. It's just one click. Just click
Hmm.
it in somewhere in a file to save a copy in GitHub. So
Yes.
we can share the link from Colab and GitHub to any interested one. It will be very
Yes.
easy because in GitHub, even in GitHub, there will be some button. When you click that button, your GitHub code will run automatically in Colab.
Uh-huh.
So everybody can run your notebook in Colab by just clicking one button in GitHub.
Oh,
So we need to think of
it
these
will be
things
great.
because otherwise our research will be living on an island. Nobody can
Yes.
access it. Nobody can make use of it.
Yes.
In
You
these
are.
days, sharing the outputs is very important to help the others, because we are
Exactly.
also using the others words as you did right now.
Yes,
So
sir.
think of this ecosystem.
Yes.
Please use Colab to write
Hmm.
your
Okay.
codes or develop
Yes.
your software, and then share to the GitHub.
Okay.
Okay, and then
Yes.
share the link with me so I
Mm.
can share the link in the video description so anybody can run your code without extra effort.
Yes, sir.
All right. So I
Yes,
am
exactly.
expecting you are sending, upload this code to Colab and make it run, then share to the GitHub, then share all these two links with me so that I can share with the interested ones in my YouTube channel. Okay.
Yes, sir, sure. I will make that as well because more importantly, as you said, the GPU usage, as you can see in the video right now, it's because of the slow nature of my laptop, I guess. It's a little bit struggling also here. So I think it will be better because of the GPU usage, and it will fasten up the process.
But by the way, I think now you open the hands and others, right? Because
Yes,
on the
in
hands,
this,
I am seeing many
yes.
landmarks.
Yes, sir. In this video, I opened the landmarks as well, not the face one, the pose and the hand. But as you can see, it misses sometime. It is just because of the slow nature or the speed limit of my laptop. So that's why it's not able to capture very fast. So that is one thing. I think, yeah. So this is actually it will get better, I think, there or
Okay,
in
but this is real time on that video, right? What we are
yes,
seeing, the output is the real time output, right?
yes,
On
it's
online.
it's a real time output. Like it's just loading the video and performing this task. But another thing is that like some missing point in this architecture is that it detects the proper pose after first detecting the nose. So that is what I am also a little bit concerned about, is that if we are only seeing the body of the human, we should be able to detect that as well. But first it detects the nose point, and from there it relates all the joints and then prints it. So as we can see, like it's struggling right now because it's not seeing the face. It's struggling, it cannot detect correctly. But let
Sometimes it jumps to the vegetables or something.
yes, yes. Let me play another video that I have here. Let me check its name first. In this one, the body is like more visible and the nose is visible like all the time. So that's why it's detecting all the points quite easily.
But the legs are still missing. I think it needs a full body coverage, right, in the video. So when it is not
Yes, yes.
full, complete,
Yes, it will just like detect those points that are visible in the video. Like because we are not seeing the knee joints, so that's why it is struggling to detect those joints
now,
because
Numan, one question, actually it is follow-up question.
yes, sir.
Now, how can we understand that, or we need to understand actually,
Yes,
but using this model that you all just downloaded and try to use,
yes,
one
sir.
model, a specific model, this specific model will give us the labels. For example, this is the junction point for the finger or for the shoulder, or I
Yes,
don't know, this is for the left side of the mount. You know, that
yes,
there should be some labeling outside, and
yes,
we need to consider this label and its location, and it is tracking. I mean that during the time, how this label position changes, it is three-dimensional coordinates.
yes,
So,
sir.
right, we need to focus on this. Otherwise, we cannot record it first of all. We
Yes,
need to record all the necessary information about the junction point, name, coordination, and the movement, the track positions. Then we need to create a movement model so that the robot can imitate it,
Yes,
right?
sir.
So this is a good beginning. So you already successfully download a train model, pre-trained model, and then you apply this pre-trained model on the webcam, real image or real-time image, and the video. It's
Yes,
good
sir.
beginning point, but
Thank you.
please note that you need to understand the output better, because then we are gonna record the output, then translate the output to some mathematical model that the robot can create some instructions for itself, translate
Yes.
these coordinates to some instructions. Am I right?
Yes, so let me, sir, I have like pen and paper. So what we need to do right now is like, as you said, first the labels of the joints it is detecting with the positions, right, sir? Labels of like what joint it is detecting and what is the coordinates of that joint. And secondly, sir, you said something about the time series of like detection or time frame of the detection. So, but how like in what sense do you think like we can get it from here in this
Assume that we
model?
have the label for the shoulder junction
Yes,
point, shoulder. Let's
yes,
say that we have a label. Then we have the coordinates of these during 10-second video, for example. So the shoulder can move on in some X,
uh,
Y, Z direction during the 10 seconds. So we need to ensure that
yes,
we
yes.
know how it moves during this 10-second in three-dimensional space. So maybe it
Okay.
stands in 3 seconds here, then moves like that, then 1 second, then moves. So we need to create this as the, for example, step motor instruction. 3 seconds, in three
Yes,
seconds, move to this position, wait for 1 second, then move to 3 seconds to this. Do you understand me? Do you follow me? So we
yes,
need
yes,
to
yes,
create,
yes. I got it.
yeah, you understand what I'm saying? We need to translate the
Yes,
movement to the instructions, because
yes.
mostly the
Like you mean
robots
to
use
say,
the step motors, right? So that's the idea.
yes, like some previous data as well. You meant to say like not just the current data, but also like the tracking of that position of the joint,
So we
I
might
think.
need to write some code
Yes,
to bridge these two from the image processing, the output of that, to
yes,
the instruction to imitate the goal of these movements. So we
yes,
need to break into the steps, and then we need to provide the instruction to the robot, whatever the robot model is. Maybe in
yes, sir.
human body, we will have
Yes,
some 10 or 12 junction point. Maybe in robot, we have only 5 junction point. So you need to map these junction points, the movement, the instruction to these movements, time, the coordinate of the time and the space.
yes,
So you understand, we need to create
yes, sir.
maybe a special model from the image output to the instruction to the computer or the robot step motor, for example.
Yes, 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 sir.
Or now, it is good beginning. Thank you for the update. But I would like to
Thank
ask
you, sir.
you what you have read during these 2 weeks. I think that you keep reading, right?
Yes, sir. I kept reading a lit.
An update for that?
Yeah, yes. I read a few papers, but not so much like a new thing because I read them basically to get some help in this, in performing this task. But as I got it from the help of some YouTube videos as well. So it wasn't like that much of. I think it's not
Okay. So for the
that
next
useful.
week, I strongly suggest you first understand the output of that program in terms of
Yes.
the coordinates, the labels, and the time tracking of these labels. Try to understand
Okay.
this. And maybe
Yes.
it is logging to a file, I don't know. If it is like that, please to analyze this log file, all right? And then think about the robot model as well, because in the robot model, maybe we will use a very simple model, like a line man, you know that very simple model, to create
Yes.
a limited version, a skeleton version of the imitation.
Yes.
So
Yes.
we need to think about the connecting model from the image or video to this simple model. And please make some reading
Yes.
about this, how the people already done this solution. So we don't need to rediscover the wheel, you know. So
Okay.
please read how
Yes.
people connect the image processing to the imitation between. Or you
Yes.
already read some papers, last time you already summarized, check these papers again in that terms, okay? So read to understand how do they connect from the
Yes.
raw data from the video
Mm.
and convert them to some instruction to the robot. How do they do this?
Yes.
Okay,
Yes.
and maybe we can invite Dr. Yücel Tekin, who is an expert on robots. Maybe we can tell what our expectation, and he can suggest us a simple, real robot. So maybe, if you like, maybe we can try to integrate the code to this robot, if you like. But it's gonna be a
Yes.
little bit hard because we need to understand its own instruction set and blah, blah, blah.
Yes.
But it is up
Yes.
to you. Okay, so next time we can discuss this. But for this
Okay.
time, for this week, it's a good step. I'm really happy that you can make it run this simple model. It's a good step.
Yes.
Now we need to understand that if the output of that model helps us or not. If it is not sufficient for us, maybe we need to change this model with another model so that the
Yes.
output will be helpful for us. Then
Yes.
maybe we need to write down a little bit code to translate the output of that model to some instructions to the robot. So therefore,
Yes. Yes.
do some reading on this part as well for the next week. Are we
Okay.
good?
Sure. Yes. Yes, sir. We
Okay.
are. Thank you so much for
Do you want to say
all
something?
the
Or?
instructions. And no, sir, I think it's fine, and I will do, and I will try to get first initially these two things, like the positions and their labels of the joint, their time relation with each other, the movement, the relation of the movement with respect to time. So I think these will be my first two main priorities, and I will try to get these things in the next week, inshallah.
If you fail to get these outputs from the model, if you fail, if the model doesn't support, please look for another model, okay? But I am sure that
Yes,
somehow they
yes,
should provide something because otherwise it is gonna
yes,
be
sir.
useless, right?
Yes, yes, sir. Exactly.
Thank you for the update. I really like that you have done by yourself in 2 weeks' time this demonstration. It's a good step. But maybe we need to think of
Thank you, sir.
creating our own model, maybe. Maybe we just created the bridging software by ourselves, or we can add the robot
Yes,
at the end of this streamline so that we can create an imitating robot on live. So we can think about this, but it's a research. It means that in each step we can change our goals, but now we are just warming up. Okay, we are building up our experiences on these topics, so we get our hands dirty. So it's a good thing, but we will spend more time, don't worry, but it's a good beginning. All right.
Yes.
Okay,
Yes, sir.
so
And sir, I have another thing in my mind. Excuse me, sir. I have another thing in my mind, like that we will need, I think, in this imitation learning, because we want, actually the last target is to detect what task has been done. So I think for that reason, we will also need to recognize other objects present in the video as well, I think.
yes, but we need to
Object detection
step by step.
and
Okay,
their
we need
labeling.
to begin with a very, very simple goal. Then we need to maybe excel this goal. But if we begin with very high target, sometimes we cannot access, and we sometimes we can get easily lost. So in my approach, if you agree on it, let's begin with very simple thing first, and let's create our stream line or pipeline, so that from a video, for example, a robot can imitate the human body movement first. Then, as you suggest, it's a legitimate suggestion. Maybe we need to recognize the environment with respect to that body movement, and we can say that, for example, move the television to the right 10 centimeters, for example.
Yes,
yeah, I understand you. But for the beginning, let's create our simple environment, a video input, an instruction set output, then a robot use this instruction set, imitate something. That's our baseline model. Then we can increment this model by adding more new attributes, as you suggest. But for the time being, I would like to work on the generic ideas. How do people solve this problem? Let's put together the pieces running together. Then we can add more attributes, more features to this pipeline. Is that okay?
Yes, sir. Yes, sir. Got it. Yes, sir.
Okay. So absolutely. In the end, I hope that we could have much more useful model in the end. Of course, it's not gonna be simple, but we need to begin with a simple model to prove the concept that it can be done.
Yes, sir.
Okay. So my suggestion is that we need to think that at the end of the model, are we gonna use a real robot? Maybe we can use a simulation of a robot. So please try to look into the literature. There are some simulation of robots. Maybe it will be easier for us to simulate this environment. And next time I can give you some simulations very used in, for example, in gaming. You know that in gaming we have several free game engines. Maybe we can use these engines to create our model and then translate the scene into a game scene.
Mm-hmm.
Do you understand what I am saying? For example, you show that the ladies cleaning a table. Maybe after processing this video, we can create a table, the flower on that table, the lady itself, and cleaning this thing. Do you understand that? We can create a scene, virtual robot to imitate the cleaning of a table. So we can use the gaming engines. There are 2 or 3, very famous free engines. You know this. Maybe we can learn this in 2 weeks, and maybe we can try to this. So the input is the video, output is these engines output as a not gaming but as a simulation. Instead of using a real robot. Maybe it will much more easier for us to code this bridge between.
Yes, sir.
Do you agree?
Yes, sir.
But in time, we are gonna decide this. Okay,
Yes,
for the
we will
moment,
decide it later.
let's go step by step. But our strategy is like that. Okay, we are gonna create a pipeline, getting the input as a video, and then the body parts, and then maybe the
Yes,
environment, and then the simulation of the robot, how to imitate this movement or this target movement.
yes, sir. Yes, sir.
Are we clear?
Yes, sir. Thank you.
Okay, you know what to do till next week.
Yes, sir.
Okay, so thank you for the demonstration. Next week, I would like to see more elaborated demonstration. And maybe you need to create some logs. Maybe you try to create the logs to some instruction, right? Maybe we can use some robots. So think about this as well and do your readings. And during the demonstration, maybe after the demonstration, you can share what you have read so far, because it's really important that you keep reading, okay, for me. So please, at the end of the demonstration, for 10 or 15 minutes, show me what you have read during the last week, okay? It is important for me.
Yes,
okay.
Sure.
During the week, if you have any problem, please send me a WhatsApp message or email so that I can help you. Do not get lost, okay? So anytime you can contact with me, anytime, okay? You know, you are accustomed to that, but I repeat it, okay?
Yes, sir. Thank you.
Don't wait until the next week, okay?
Yes. Okay.
All right. Thank you for the demonstration. See you next week. Bye-bye.
See you, sir. Thank you. Bye-bye.